This is Manoj here. I'm having around 20 years of industry experience. So today's topic is AWS DevOps. So we will talk about a little bit on the DevOps. So guys, this is advanced topic. So what I'll do is quickly I will give introduction of DevOps. Okay, then we'll touch upon the advanced topic, which is AWS DevOps. What is SDLC lifecycle? SDLC lifecycle is nothing but it's a combination of multiple phases. Okay, this fixed phases which we usually work in the SDLC lifecycle is requirement gathering, design, development, maintenance, deployment, testing, and the maintenance. So guys, whenever we work for a new software development or when we want to go and kind of fix any issues or work on the greenfield project, we have to follow SDLC lifecycle. Okay, right? SDLC lifecycle. Now, along with the SDLC lifecycle, guys, we have to follow one of the delivery model also. So if I talk about one of the famous delivery model that is called waterfall model, what waterfall model says is you run this SDLC lifecycle. You run this SDLC lifecycle as water flows from top to bottom. It flows as a whole. So you run SDLC lifecycle accordingly. Okay. For example, if you have a project is there and that project has 10 modules are there. Okay, so and you have 10 months is being allocated. So what you must be doing is, or let's say 6 months are allocated. Okay, so what you must be doing is you must be doing requirement gathering for all the 10 modules together. Then you must be doing design for all the 10 modules together, development for 10 modules together, deployment for 10 modules together, testing for all the 10 modules together. Now guys, suppose when I must be reaching to the testing phase, out of 6 months of time, I would have completed my 4 to 5 months of time, maybe because requirement gathering took 1 month of time, design took 1 month of time, development take 1 month of time, deployment took 1 month of time. So by the time I must be reaching to the testing phase, it would be completing almost 4 to 5 months of my time. Now after 1 month, I have to go live. So assume that guys, if I get a major defect in the testing phase, then I will not have time to fix it. And this leads to a bad delivery for me. This leads to a major issue for me. So why and what was the problem with the waterfall model is I was not getting quicker feedback. Okay, not getting quicker feedback. This is the biggest issue with this, waterfall model. So people move to a different methodologies wherein we are going with the incremental release. So we will be running this SDLC lifecycle for one module at a time. Okay, so basically we are doing nothing. Instead of big bang approach, we are going with the incremental approach. Okay, so like requirement gathering, design, development, deployment, testing, and maintenance. What we'll be doing is all together we will be running entire show for one module at a time. So we have 10 modules are there. So what we must be doing is we must be running this thing for 10 modules. This life cycle will be running 10 times one module, one life cycle. Okay. And what is the benefit with this is the benefit with this is after first life cycle completion, if you get to know that there is a major defect is there, so what you must be doing is you must be doing fixing for the defect in the next life cycle. If you have any issues in the next life cycle, you can fix it in the next life cycle. So the duration of this one life cycle is 3 to 4 weeks of time. Okay. Now what is the benefit with this approach is that by the time your all the life cycle will be completed, you will be able to fix all of your defects. Okay, so with this model you are getting actually on-time feedback or quicker feedback. Okay, you are getting quicker feedback with this model. Okay, with this model you are getting quicker feedback, and this model we are calling it as a agile methodologies. Okay, this model we are calling it as agile methodologies. So with the agile methodologies, theoretically my most of the problems are being fixed. But guys, if you see practically now my challenges has been increased. Earlier I had to do everything in good amount of time, 6 months of time. Now, okay, multiple deployment testing, I have to do 6 months of time. Now for each and every cycle, I have to repeat couple of deployments, couple of testing cycles, couple of development cycles. Maintenance also has been increased. So much manual effort has been increased. Apart from that, if I have to meet this 3 to 4 weeks of timeline, then I have to be very much kind of collaborative with each other. All the people have to work together. Okay. So what are the challenges which, or what are the demand of the situation which arises is, we want a lot of things like testing to be automated. Okay. And we want deployments to be automated. We want environment maintenance to be automated, environment simulations to be automated. Okay. We want code quality to be automated, code coverage to be automated. Okay. Code builds to be automated, packages to be automated. Okay. And we want more collaboration between the teams, and we want more control on infra. So these problems are there which we are facing, which people want solution. So how it can be solved? Automation, right? So how it can be solved? It can be solved using automation. And what sort of automation we are looking for? We are looking for application level of automation, or which is nothing but DevOps. Okay. So this is how, guys, DevOps mechanism has come into the market. Okay. This is called DevOps. Okay. Now if someone will ask you what is the difference between Agile and DevOps, then you can say that Agile and DevOps both goes hand in hand. Without Agile, you will not see power of DevOps, and without DevOps, you will not see power of Agile, right? Agile and DevOps both goes hand in hand. Let me make a good symbol so that you'll be comfortable. Okay, Agile and DevOps both goes hand in hand. Without Agile, you will not see power of DevOps. Without DevOps, you will not see power of Agile. That is how the relationship of Agile and DevOps is there. Now, guys, this is what basics of the DevOps. Now, DevOps has couple of principles are there. So what are the different principles of DevOps are there? Different principles of DevOps is there called continuous integration, delivery, deployment. Okay, continuous integration, delivery, and deployment. Let me write down most of the phases. Then, guys, we'll discuss what are the traditional tools are there, what are the cloud native tools are there, like what is the AWS DevOps tools are there, which is offered to cater the same thing. Okay, continuous testing, continuous monitoring, multiple phases are there of DevOps. Configuration management has come as a part of continuous delivery. So guys, whenever a developer he develops the code, he check-ins his code into a version control system, VCS. Okay, there are multiple version control systems are there like Git, GitHub, okay, and CVS, TFS. A lot of version control systems are there. So for example, a developer when he checks in the code, what he does is he checks in the codes into the version control system. Now, guys, the biggest challenge here is we have to manage our SDLC lifecycle for 3 to 4 weeks of time. So if I have to manage the lifecycle of 3 to 4 weeks of time, then I should give feedback to a developer about his code as much as I can. Okay, like what is good in his code, what is bad in his code. What kind of feedback can be given to a developer, guys? Code quality, static code analysis, code coverage. So guys, we can ask him to give whether your unit test cases are passed or not. What is the level of unit test cases you have covered, that is in code coverage. And we can tell him what is the quality of the code of his code quality. And we can give him security level feedback also, and whether his packages are getting built or not. All these feedbacks can be given to him. Yeah, builds are passed, phase. So what will happen is, guys, if I'm giving all this feedback to him on time, then the probability of having more defects into the production will be less. Probability of having more defects into the production will be less. So guys, if any developer will be getting a chance to get such kind of feedback, will he be encouraged more to check in his code very often into the version control system, right? This process we are calling it as a continuous integration process. What is the traditional tool is there that we are using for any of the version control system? What are the most famous tool is there in the market for version control system? GitHub, right? Remote repositories, GitHub. So GitHub is one of the tool. But guys, do you know where GitHub is keeping the code of your repository? Do you know the location? cloud, but you don't know the location. It's their own cloud, right? We don't know, right? Okay. And apart from that, guys, which is the tool is there by which I can make this pipeline? I can integrate unit test cases, code coverage, security, everything within the pipeline. What is the tool is there for continuous integration? Jenkins. Jenkins is the tool, GitHub is the tool, traditional tools are there. Okay, so what we can do with the guys, cruise control, but most famous tool is Jenkins. Okay, so basically, guys, Jenkins will help you to do two things. It will help you to create the pipeline, and it will help you to do continuous integration, or it will help you to do builds for your artifact, right? Right? It actually gives your pipeline, and it actually do a build for you. And which build script can be used when it builds? Any build script, right? Maybe ant script, maven script, or any build script, it can be used, right? So guys, where this build will be happening, which machine, this ant and maven? Mostly in the master machine. So who will be managing your compute capacity in that case? Jenkins master, right? Jenkins master will be managing compute capacity. Biggest drawback here is, who will install the Jenkins? Who will do the maintenance of Jenkins? It's we. DevOps team is a part of your team. Is it not a headache for you? Is it not an overhead for you? Right? If anytime Jenkins is down, you will be responsible, right? So guys, what cloud is doing nowadays is, you use my tool. As you pay model is there. Okay, we will take care of your maintenance part, patching part, upgradation part. You just use it. For example, guys, when we use WhatsApp, do we need to take care of what is the patching is happening when the WhatsApp backend machines are down? Are we bothering all these things? No, right? So what AWS is telling, that not only AWS, guys, if you take example of Azure also and GCP also, everyone is giving now their own services to cater the DevOps world. Okay, so to cater the version control system, they are giving a tool. AWS is giving a tool called code commit. Okay, a service called code commit. For pipeline purpose, okay, they are giving a service called code pipeline. Okay, and for managing builds, they are giving a service called code build. So guys, these three important services are there, which are the part of continuous integration, which AWS has launched to cater the DevOps world. Okay, let's discuss about the CD part. Code build is nothing, guys. Code build is a service, okay, which will allow you to provide you the compute capacity. Now let's move on to the next topic, which is delivery and deployment. So guys, let me make some more diagrams here. Okay, so what I'm doing is, I am deploying my code into the dev server, and then I'm deploying my code to the QA server. Then I'm going for a testing, then I'm going for QA server, and then I'm going for testing. Then I'll go for pre-prod machines, and then prod machines finally. Pre-prod, and then finally we are going to the prod one. We are going to the prod one. Before we'll go to the prod, do we need to have any approval from the service management, or we can go directly into the prod? We need approvals. So guys, if you make your process very robust and automated, like after dev, automatically testing will be started, after QA testing will be started, pre-prod testing will be started, then you can go directly to the prod. Facebook has a vast development areas are there. They're releasing 1,000 features in a day. That's why they have 1,000 deployments are there. So guys, the process which allows you to go to the production without any manual intervention, we are calling this process as a continuous deployment process. The process which allows you to have the process which allow you to go to the production with some manual intervention, we are calling it as a continuous delivery process. So guys, at the moment, most of the companies, they are in continuous delivery process only, but the intention of the industry is to move into the continuous deployment model. So the aim of the industry is to move to continuous deployment model. In the CD, the difference between continuous delivery and deployment is, continuous deployment is nothing but it allows to go into the production without any manual approval. Continuous delivery, it allows someone to go into the production with a manual approval. Okay, so when you don't require any approval, you have seamless processes there. We are calling it as a continuous deployment. Otherwise, you have to call it as a continuous delivery. Now, guys, when you go for a deployment, okay, when you go for a deployment, there are a lot of tools are there in market. So nowadays, guys, two type of strategies has come into the production: VM based model, and another thing is container based model. Container based model. So these two models are there. So guys, when we go precisely for the VM based model, what are the deployment tools are available in the market? Lot of tools are there, like Ansible is there, Chef is there, Puppet is there, Salt Stack is there. Lot of tools are there which people uses. What are the other tools are there, guys, which their users? UCD is one of the tool. Urban Code Deploy. Lot of tools are there. Okay, Zabbia Labs has one more tool. Okay, so there is no, and I mean there is a tool is there which I am forgetting. A lot of tools are there. There is no count of the tools nowadays. Most famous tool is Puppet, then Chef, and Ansible. Ansible is the number one tool at the market. These traditional tools are there, guys, in the market. Okay, apart from that, guys, when we talk about the AWS world, again, guys, these tools, who will be installing, who will be doing the maintenance, who will be purchasing the license for you? We, our company, right? Whether we are using for 10 nodes or 100 nodes, you have to pay for minimum combo package and you have to do a maintenance, right? Client or our company, I mean, someone has to sponsor this thing. So let's say if I purchase, guys, 100 node license, and if I'm using for only 10 nodes, will I be paying for 100 nodes or 10 nodes? Guys, deployment tools come with the node licenses on how many targets you'll be deploying it. 100 nodes you'll be paying for, right? So again, that is a overhead for me, right? So AWS comes with some services to cater the same world. So Code Deploy is a service which is being used for deployment purpose. And there is one more service is there called OpsWorks and Beanstalk. This service is there, which is given by AWS company as a AWS DevOps. Okay, now guys, container based world is also there nowadays. So in the traditional world, guys, what are the container based tools are there? Which is the best container is there? Docker, right? Docker is the basic tool is there. Which is the repository for Docker is there? Docker Hub or Docker registry, right? Which is the container orchestration tool is there, guys, in market? Number one, Kubernetes, right? Kubernetes, these tools are there, which are traditional tools of our industry. Now, equivalent to them in DevOps of AWS, they're offering three services. Again, guys, who will be installing the Docker? Who will be installing the Kubernetes? Who will be installing the V? Everything we have to do it, right? DevOps team or our team, right? So, guys, here we have services are there. So for containers, we have Elastic Container Services are there. We call it as a ECS also. Elastic Container Registry is there. Which is called ECR, Elastic Container Registry. And for orchestration purpose, we have Elastic Kubernetes services are there. We are calling it as a EKS. So guys, these services are being offered by AWS as a part of AWS DevOps. Now guys, when we go for the monitoring purposes, what other services are there in the traditional world? Or tools are there, like Nagios is one of the tool, right? Okay, and App Dynamics is one of the tool. Okay, a lot of tools are there. There is no count, a lot of tools are there. Okay, so what AWS says is, you come to me, I will give you my traditional services to do the same thing. Again, guys, App Dynamics or Nagios, New Relic, many tools are there. Who will be installing again, guys? I myself will be installing, right? So AWS is offering two services, CloudWatch, CloudTrail. These two services AWS is offering. Now, apart from that, guys, we have all the services are there. Okay, so the beauty of cloud is you can go for on-demand environments creation as well. We have something called on-demand environment creation. What is the services there to set up the infrastructure in AWS? Quick setup of infrastructure, how we can automate this using cloud formation templates, right? So cloud formation is the another guy which is available in market. This is very important component of AWS. Okay, cloud formation script. So in short, guys, we have multiple services are there. 4 services, if I summarize, we have code commit is there, which is like a version control system. Code build is there, which is like compute capacity. Code pipeline is there, which is equivalent to the Jenkins. Code deploy, which is equivalent to the code deploy tool. Okay, and we have Docker. 3 services are there for Docker: ECS, ECR, and EKS. Then we have CloudWatch, CloudTrail, CloudFormation. A lot of tools are there. So these tools we are calling it as a AWS DevOps. Now guys, what is the biggest benefit when you go for on-premises tools and when you go for a AWS native tools? Maintenance, guys, maintenance and cost. Nowadays, everyone wants to go for tenant-based model, right? So this is the benefit. Okay, so guys, let's start few things on the hands-on part. So this is the advanced topic. What is the prerequisite is for this particular AWS DevOps is you should know the traditional DevOps and you should know the basics of the AWS. So I will not go and walk through any of the concept of AWS, but I'll tell you what are the services are used for what purposes. So guys, I mean, if I go to AWS on the AWS console, when I go to the services, you will see for multiple purposes we have different type of services are there. So if you see here on the DevOps purposes, we should have AWS code commit, code deploy, okay, and other services are there. For example, you can see here for containers, we have Elastic Container Registry, Kubernetes services, and container registries are there. Now let me check other services they are in which particular item. So you can see here code build is there, code commit is there, code deploy is there, code artifact is there, multiple services are there. Okay, so let me go to the code commit service. Okay, code commit, this is the code service commit services there. So what we can do is we can create a repository, okay, and if you want to see the pricing and all, you can see it here. Okay, but what I'll be doing is, guys, at the moment I have logged in from my root user Manoj3004. This is my root user. So whenever you will be creating a repository or you want to do anything, always do it with a secondary user. So the service which will be used to create a user is called IAM service. Okay, so let me search here, manage access to AWS resources. So let me create a resource here. Okay, let me create a user here. Okay, add user. I can give name as a Edureka user or Edureka123 as a username. I will give him programmatically access. I will give him management level access. Let him auto generate the password. I will give him permissions. So it asks me to create a group and add it. So let me create a group called admin group. Okay, I've created this group. I need to assign some permissions to this guy. So what I can do is I can assign administrator access. I'm giving him full permissions to this guy, and then I'm creating this group. So this user is a part of admin group. Okay, and let me add tags. I need not to tag. Let me just review it and let me create this user Edureka123. The username I'm giving him programmatically and management console access, auto generated password access. He's a part of admin group, and what policy is being assigned to him is he can change the password, okay, after he logged in first. Okay, so let me create this user. Now what I can do is I can download these credentials. So these credentials are being downloaded. So let me pick up these credentials. So you can see here, guys, this 6 user credential. This is the credential which I just downloaded. Let me delete other credentials. Okay, so this is the user what I created. And this is the username, this is the password. Now guys, when I go to this link or when I go to this users, when I go to this user, I have a different type of credentials are also there, security credentials. So here I have some credentials are there called generate credentials for AWS code commit. So guys, there are two type of credentials are there for any user. One type of credential is there to log in into the AWS, and second is how to connect to this code commit service. So let me create these credentials. Let me keep it somewhere, or probably I can download this CVS also. This is my user and my password is this one. This is my user credentials to create with my repository. Now what I'll do is guys, I will go and log in with this particular user which I just created. Let me open this user, and this is my account number. This is my account ID. Next. Okay, I can give my old password and I can give my new password. So because we have set the policy, first time you have to change the password. You can see here guys, this user has been created. Now what I'll do is I will go and access my code commit service. Let me create a repository here. The repository is practice. This repository has been created. Now I want to connect this repository with my local repository. So what I'll do is I have a machine is there. Let me create a folder here, make directory. Let me go and enter this directory, and then let me paste this URL, or let me copy this git clone, and whatever the remote repository URL I have pasted. So it's asking for the username by which we have to connect. So in the Notepad++, we have already. So this is my Edureka 123 code commit credentials. My username is this. So I have one virtual machine is there guys, wherein I am actually passing this password and username. Okay, so you can see that I have connected to my repository. Now I can create some files here. If I'll type here git status, you will see nothing is there. Let me go to this practice repository, which is an empty repository. So if I'll do git status here, nothing is there. Let me add some commit. Touch one.txt, git add dot, git commit -m added one.txt file. Now what I'll be doing, let me add some more files. Git 2.txt, git add dot, git commit add. Let me add 3 files. So what we have done is we have added 3 files into this repo. Nothing is there to commit. Now we will go to our code commit. And here we will see how we can push our files from local to the remote. So what I'll be doing is git push, I'll be typing here. Okay, again username and password it must be asking. And this is the password it's asking to push the content. Unable to access. Why? Hey guys, username was wrong. That's why I was not able to push. So our content has been pushed here, guys. Okay, if you want to add a file, you can add a file, you can upload a file. Okay, and in the left hand pan, guys, there are a lot of things are there. You can create a branch also within the existing branch. Okay, so what I'll do is let me add a file and then we will pull it. Let me give a file name d.txt, author name Manoj, commit changes. Now guys, I want to pull this change into my local repository. So what I can do is I can type the command git pull. Okay, again it's asking for the credentials. It asks for the password. So it is added d.txt in my local file. Okay, so guys, I can pull easily, I can push easily. Now guys, what I can do is I will tell you now a scenario. This was the basic one. Now I'll tell you one of the important concept here called branching and merging. So you can create a branch from the master branch, the default branch. You can create a branch, feature branch, Okay, from which branch? From master branch. I've created this branch, feature branch. Let me go to my feature branch and let me add some contents. Let me add one more file, e.txt, author name again Manoj, commit the changes. Now guys, suppose you are working in a development environment, so you have created two branches, your master branch and a feature branch. Now guys, suppose you want to merge your feature branch into your master branch. So you can raise a pull request. You can go to the pull request, you can create a pull request. Okay, if you want to compare your master to feature, what changes are there, this compare tool will tell you, or compare option will tell you. Okay, and then you can create a pull request by saying my first pull request, create a pull request. Okay, and then it's saying no merge conflict, you can approve it, I can merge this. Okay, what kind of merge you want, fast forward, squash, three-way merge. Let me merge pull request. Okay, so you can see here in my master branch, this change has been merged. This change has been merged, e.txt, which I created in the feature branch. Let's say I am a developer and owner of my branch is someone else. Will you allow myself to merge my content into my feature branch? Does it make sense? To master branch, feature to master branch, will you allow me to merge the contents? In real-time scenarios, that shouldn't be a case, right guys? So let me do one thing. Let me create a feature branch. Let me create some contents in my feature branch. Let me go to my branches. Let me pick up my branch. Let me create a new branch. Okay, this feature branch I created. Let me add some file here. Create a file. I will create a file with the name of merge.txt. Author name again Manoj. Email manoj@gmail.com. I will commit the changes. Now what I will be doing is, guys, I will restrict Manoj not to raise a pull request, or if raise a pull request, not to allow him to merge. See, old feature branch was deleted, Ajay, when you merge a feature branch to the master, there is an option is there. Okay, and I forgot to unclick that, uncheck that. That's why that feature branch has gone. Okay, so this time we will take care that we will not delete it. But guys, for that, first what we have to do is we have to go and set up some policies in my this user, Edureka user, so that he will not able to, he will able to raise the pull request, but not able to check in anything into my, or not able to merge any change into my master branch. I will go to my user, this user, and then I will go to its policies, add permissions. Let me go to this group, and I have some permissions are there, something called inline permissions or inline policies. Let me add some inline policy here, custom policies. I can give some policy name that blog pull request for this user. And in the policy document, I can pass the policy XML. There is a XML is there. So this URL, guys, you can see. Okay, you can see this URL. Here they've clearly mentioned if you want to block someone to, raise a pull request, limit pushes and merges branches in the AWS commit. And this code is there which we have to pick up. I can paste it over here. But guys, here few things are there. At the moment, it is applicable for each and every domain, region, and each and every or the particular repo only. So what I'll do is I will make some changes here. Probably I can show you the previous examples also. Okay, let's say this junior developer. Okay, I can see his policy, edit the policy. You can see here they have done star star star. Probably I can pick up this guy only better. AWS code commit star colon star, and what I'm denying, git push, delete branch, put file, merge branches by force forward, squash, everything I'm blocking for this user. Apply policy. Now you can see this policy block pull request has been applied for the user Edureka 123. Now I will go to my service, which is code commit. Now if I'll be raising a pull request, you will see that this pull request will not be fulfilled. I'll go to this repository. and then I'll be raising the pull request. Create a pull request from destination is master branch, source is feature branch. I will compare. There are no conflict. I will raise a pull request. Let me give the blog pull request. Let me give it name as a blog pull request. I will create a pull request. Let me merge it. Fast forward merge pull request, and you can see here that it's saying you are not entitled to raise any of the pull request. Okay, you have explicit denies there. So like that, guys, you can block anyone to raise the pull request. In this, you can see here left hand side for code build, we have code build services there. For code deploy, we have code deploy services there. For pipeline, you can code pipeline services there. So a lot of services are there for different purposes. So this was just a kind of overview session, and with that we'll wrap up the session, guys. Thank you guys for joining the session. Bye for now.